Okay, this video is going over simplifying trig expressions and also factorizing trig expressions. Okay, so for the first part, we're going to use these two identities up here. Sine squared plus cos squared equals 1. And tan theta equals sine theta over cos theta. So you should be familiar with those. Okay, but for the first question, it's very simple. It says 6 cos theta plus 8 cos theta. What's that? Well, it's like 6x plus 8x. That's just 14x. So 6 cos theta plus 8 cos theta is just 14 cos theta. Okay, similarly, 5 sine theta minus 7 sine theta is just negative 2, because 5 minus 7 is negative 2, and it's just times sine theta. It's like sine theta is just like a variable or something. Okay, for the next one, 6 minus 6 cos squared theta. Now, at the moment, hopefully, what you'll notice is cos is being squared, and hopefully that makes you think you might need to use this first identity. To easily recognize it, factorize the 6 out, so what's left in the brackets looks a bit more like the identity. So if we take 6 out, we get 1 minus cos squared theta. Now hopefully now you'll realize that from this identity up here, if I were to move cos squared theta to the other side, I would get sine squared theta equals 1 minus cos squared theta. So if that's the case, then I can replace all this with just sine squared theta. And remembering, we're just simplifying these expressions. We're trying to find a way to write them in a shorter way. And we've done that, because 6 sine squared theta is shorter than the original. Okay, look at the next one. We've got a lot of squares here and a cubed. So again, that's a hint to me that I'm going to use this first identity. So now I'm thinking, if I take sine theta out, because I notice sine theta is in both terms. It's in here, this term and this term. So let's see what happens when we take sine theta out, see if we recognize anything. If I take sine theta out of the first term, I'm just left with cos squared theta. If I take 1 sine theta out of the second term, I'm just left with sine squared theta. Oh, wait a minute, this is the same as this identity, so it would all just equal 1, or everything in the brackets would equal 1. So then we get sine theta times 1, or just sine theta. Next one, cos theta plus sine theta all squared. A lot of people think that this actually equals the same as this identity, sine squared plus cos squared. But remember, if you think about a perfect square like a plus b all squared, we actually get a squared plus b squared, and then we got this 2ab term in the middle. So we can't forget about that. So let's use that idea to expand these brackets. All right, we get cos squared theta plus 2 sine theta cos theta. I could have written cos theta sine theta as well. I'm just used to doing sine first. Plus sine squared theta. Okay, so that's using this perfect squares rule here to expand the brackets. Now, it's up to you if you need to rewrite it, but hopefully you realize that this cos squared theta plus sine squared theta is again just this identity. So all of that adds up to the number 1. And then we've got plus 2 sine theta cos theta. And that's it. Now, if you're in a course where you also know the double angle rules, then you'll also know that this could be simplified, could be rewritten again as 1 plus sine 2 theta. But you may not be up to that, so don't worry about this line too much if you haven't seen that before, that 2 sine theta cos theta equals sine 2 theta. If you haven't seen that before, you probably just wanted to stop at this line here. I'm going to rub out that last line to make more room for the next example. Okay. 4 tan theta over sine theta. Now, we should remember that tan theta is sine theta over cos theta. So let's put that in there. On the numerator, we get 4 times sine theta over cos theta, all divided by sine theta. Now, in this form, it might be a bit hard to know how things cancel. So if you need to, rewrite that. So now I'm going to just write the numerator part. And remember, this is like 4 on 1, 4 over 1. So we get 4 sine theta over 1 times cos theta, which is just cos theta. And then think of it as all of this big fraction divided by sine theta. Now that is the same as 4 sine theta over cos theta times 1 over sine theta. Because when you divide by something, so like sine theta is the same as sine theta over 1. If I divide by that fraction, I'm timesing by its reciprocal, which is 1 on sine theta. Hopefully now you can see that sine theta here and sine theta here cancel out. So we get 4 times 1 is 4 over just cos theta. And again, if you know the other reciprocal functions, like sec theta, if you've learned that sec theta is 1 on cos theta, then you'll know that this also could equal 4 sec theta. But again, that may not be part of your course, or you may not be up to it yet, so don't worry too much about this part if you've never seen that before. So that's a bit on simplifying trig expressions using these identities up here. Now we're going to look at factorizing trig expressions. All right. First one. When I look at that, I see 2 squares and a difference or subtraction. So I think of difference of 2 squares. Just a reminder. If you have x squared minus y squared, that equals x minus y times x plus y factorized. So we can use that difference of 2 squares identity to factorize part A. So this becomes sine theta minus cos theta times sine theta plus cos theta. Now you might be thinking, well, why don't we just use that identity that we were using earlier, sine squared theta plus cos squared theta equals 1. You got to think about it as we weren't asked to simplify this expression, we were asked to factorize it, which we've done. Now, if we did use, let's just have a go, if we did try to use the identity that's sine squared theta plus cos squared theta equals 1, then again we can think of it as cos squared theta equals 1 minus sine squared theta. Then now I'm going to try this technique. Let's have a look what happens, but know that this is actually a correct answer that we could just stop at. But I just want to show you, what if you thought you had to use the identity? So then we would get sine squared theta minus cos squared theta, which is 1 minus sine squared theta. I make sure to use my brackets so I don't mix up my subtractions. And so then I'll get sine squared theta minus 1, but minus times a minus is a plus sine squared theta. So that becomes 2 sine squared theta minus 1. Now the good news is I can still use difference of 2 squares. What's being squared to get 2 sine squared theta? Well, that would be root 2 sine theta. All of that is being squared. And then what's being squared to get 1? Just 1. So then when I factorize it, I get the first term minus the second term being squared, and then plus. So what I'm saying is, this is a correct answer. That's all we actually had to do. This is also a correct answer, a correct factorized answer, but if you were trying to use the identity, if that's what you thought you had to do. So I just wanted to show you that it's possible to also use the identity and find a different factorization expression. Okay, so now I'm going to rub all that out so we can go back to part B. All right, next. So when you look at part B, cos squared theta minus 5 cos theta plus 6, it may help you to replace cos theta with x. It's up to you if you need to do that. But so if we let x equal cos theta, then what happens? This then would be x all squared, because that's cos theta squared, minus 5 times x plus 6. Now hopefully that is an expression you can easily factorize using whatever method, PSF or whichever method you choose. I use the method that I just write the brackets. What are two numbers that multiply to 6 and subtract, or add I should say, to negative 5? That would be x minus 2 and x minus 3. You can expand that just to check it. And now, but wait a minute, I can't leave my answer in terms of x when my original was in terms of cos theta, so I need to put cos theta back in there. And that's my final answer. Now, some people could go straight from there to the last line, and that's absolutely fine. But use the substitution if that's going to help you identify what to do. Okay, now I'm running out of room again, so I'm going to put question 3a over here. So now we want to simplify again. And simplifying suggests that maybe we'll need some of those identities that we used before. Maybe not, we'll see. But given that it's under the factorizing heading, there's probably going to be some factorizing involved. So I look at part A and I think, well, I can see I can take 2 out of the top. Really, with complicated expressions like this, just think, well, what can I see that I can do? I don't know where I'm going to go with it, but just try something. So first I'm going to take 2 out of the top, and I get 1 minus tan squared theta. And that's still all over 1 plus tan theta. There's really nothing I can do with the bottom. It's just 2 terms. Now, the one identity we could use is tan theta equals sine theta over cos theta. But if I replaced both those tans with a fraction, that's going to make it more complicated. It's definitely not going to simplify it. So I don't think I'm going to do that. But hopefully now, by looking in these brackets, you see that that's a difference of 2 squares expression, and we can factorize it. So 2 outside of, okay, using difference of 2 squares up here, what's being squared for the 1? Well, just 1 is being squared. What's being squared for tan squared theta? Well, tan theta is being squared. And then we just put one of them as plus and one of them as minus. And then at the bottom, we have 1 plus tan theta. And hopefully now you can see that we can cancel out this whole bracket and we can cancel out the whole denominator. Because with cancelling out in fractions, this bracket here is a factor of that numerator. That's why I can cancel out. Okay, and so we're left with what's left, which is 2 outside of 1 minus tan theta. And we're finished. Okay, let's try B. Okay, so looking at all that, well, I can see that I can factorize the top by taking the 3 out, and the bottom is again difference of 2 squares, so I'll factorize that too and see where it takes us. So at the top, on numerator, I take 3 out, and we get cos theta minus sine theta. Now, again, you might be thinking, well, why don't we use the identity cos squared plus sine squared equals 1, since there are squares? But that might make the denominator in terms of just sine or just cos, but it doesn't help us with the numerator, because the numerator still has both sine and cos, and therefore I don't want to do that. So let's just focus on factorizing it. Using difference of two squares again, I get cos theta minus sine theta, cos theta plus sine theta. And now we can see that this factor of the top and this factor of the bottom cancel out, and I'm left with just 3 over cos theta plus sine theta, and I'm done. Because again, the question said simplify. Simplify means find another way to write this, but in a shorter way. And this answer is shorter than the original expression. Okay, so for the last one, a lot going on here. I'm thinking we need to, at the moment, looking at that, I can't see any way to simplify these individual fractions while keeping them separate. So I think we need to combine them. We need to actually add the fractions. Now remember, when you add fractions, like if I want to add 1 on 2 plus 1 on 3, you would find a common denominator of 6, or in other words, the new denominator would be 2 times 3. And then I would times this numerator by 3, and this numerator by 2, or the other denominator. We've done that a million times with numbers. Let's do it now with this expression. So just like in this example, our new denominator is this denominator times this denominator. Okay, so it's 1 plus cos theta times sine theta. And then I want to times this numerator by sine theta. So I get 2 sine squared theta. And then I want to add, because it says add between the fractions. And then I want to multiply this by the other denominator, or 1 plus cos theta. So I'm going to write that out so I don't go too fast. You get 2 plus 2 cos theta times 1 plus cos theta. Okay, we need a bit more room. Okay, so let's expand the whole thing, at the top at least. Okay, so I get 2 sine squared theta plus 2 times 1 is 2, 2 cos theta plus, 2 times cos theta is 2 cos theta plus 2 cos theta times 1, that's another 2 cos theta, or in other words, I get 4 cos theta plus 2 cos theta times cos theta is 2 cos squared theta all over. Now I prefer to have the sine theta out front, and then the brackets of 1 plus cos theta. Alright, a lot's going on up here. One thing I notice, I've got 2 sine squared theta plus 2 cos squared theta. And if we take 2 out of those two terms, I get 2 times sine squared theta plus cos squared theta. And hopefully we know by now that's just the number 1 in there. Okay, and then I've also got these 2 plus 4 cos theta, which I don't have anything to do yet. So I'm just going to copy it. And then I have to copy all that denominator. Sorry. Okay, I'm running out of room. Alright, so I'm going to go over here now. This, what's in the brackets here is just replaced by the number 1. So I get 2 times 1 is 2, plus another 2 here is 4, plus 4 cos theta all over sine theta times 1 plus cos theta. Hopefully on the numerator you see that we can take 4 out. 4 outside of 1 plus cos theta times sine theta, over sine theta times 1 plus cos theta. And hopefully now you see we can cancel out the factors of 1 plus cos theta and 1 plus cos theta to get 4 over sine theta, and that's our final answer. Unless you know that the reciprocal of sine theta is cosec theta, so you could rewrite that as 4 cosec theta. But if that's not part of your course yet or at all, don't worry about the last bit. You would probably just end it there. Okay, so that's on simplifying and factorizing trig expressions using two identities.